Okay, this is one of the extra homework questions. I'm going to look at question 14 because it's a bit different. So it says a particle moves along a straight line with constant deceleration. It passes point A, B, and C. So let's start a sketch. So we want A, B, and C. A, B, C. Okay, it passes A at t equals 0, it passes B at t equals 4, and C at t equals 10. AB is 55.2 meters, and AC is 120 meters. So if we subtract that, that means that it's 64.8 meters. 64.8 meters from B to C. Right. Okay, now it's moving in this direction, so that's our positive direction, and it's moving with negative deceleration, but we don't know what that is. So if we think of SUVAT, okay, so distance, yeah, initial velocity, don't know, final velocity, don't know, acceleration, don't know, time, we do know. So the problem with this question is it doesn't fit into any of our equations at the moment. So we need to try and do something a bit clever. So what we're going to do, we've got two things that we don't know. Two of either u, v, or a. So we're going to basically make ourselves a simultaneous equation. So I'm going to take this first section, AB, and work out the final velocity. And then I'm going to take the second section, BC, and I'm going to use this V as my U. And using that is going to let me find the acceleration. So how do we do that? So let's start with AB. So from A to B, I'm going to use S equals Vt minus a half AT squared, because I know what the displacement is and I know what the time is. So let's substitute into that. So the first bit, I'm 55.2 is my displacement, and I know the time, that's 4 seconds. And what I'm going to do, I'm going to call my final velocity V, B, because it's V at B. Okay. And then I'm going to take away from that 1/2 A times time squared, which is 4 squared. Okay, so let's tidy that up a bit. So we've got 55.2 is equal to 4 VB minus 4 squared is 16, half of that minus 8A. Okay, now what I want is I want to put this in terms of VB. So VB, the thing that I'm going to substitute, remember we're doing elimination, just like a simultaneous equation, that's going to be equal to 55.2 plus 8A, and that's all divided by 4, because 4 VB. Okay, now the second part. If I do BC, now I want to do S equals UT plus a half AT squared, because I'm looking at the initial velocity. And what I'm going to do, I'm going to use the final velocity at B as my initial velocity. So my distance is going to be 64.8. That's equal to UT. Well, time this time is 6, 10 minus 4. Now I'm going to use my VB as my initial velocity. And I'm going to add half A times 6 squared. Okay, so let's substitute in my VB. So 64.8 equals equals 6 times, and my VB is this, so that's 55.2 plus 8a over 4. And then add on my 6 squared, which is 36, half of that, 18, so I'm going to add 18a. Right. Okay, so let's just expand that out. So I've got 64.8 equals, well, 6 divided by 4 is 3 over 2, which is 1.5. 1.5 times these things inside the brackets. And that gives me 82.8 plus 12a. And then I've got the 18a on the end. Again, if I just collect together the like terms, that means I can take away 82.8 from both sides. Minus 18 equals, put my a's together, I've got 30 lots of a, and then a is equal to negative 18 over 30, which is negative 0.6. So there is my acceleration. Now that I've got acceleration, I can use one of my other formulas, like S equals ut. Let's do S equals ut. Right, so if I do S equals ut plus half a t squared for AB, so I know my distance is 55.2, and I'm going to do, I've got ut, so my time is 4t, okay, and I'm going to add 1/2 of my acceleration, which is minus 0.6 times t squared, which is 16. So 55.2 equals 40 minus 8 times 0.6. Oh, so that's u, isn't it? U. Okay. So now I do 0.5 times 0.6 times 16. So yeah, minus 4.8. Okay, so I can take 55.2 minus my 48, oh sorry, plus my 48, sorry. 55.2 plus 48, and I'm going to divide that by 4. Okay, so I've got 25.8 equals my initial velocity.